Hello and welcome to 12.2 Notes. Today's lesson is on surface area. And the surface area of a three-dimensional polyhedron is the sum of the areas of its faces. Okay, it's the sum of the areas of its faces. Or another way to look at it, the surface area is the sum of the areas of the surface of the three-dimensional figure. For example, if I threw a die to you, a die is just one dice, right? Plural is dice and singular is die. So if I threw to you one die, and you have the side or the face that has the one dot on it, and the side that has the two dots on it, and the 3, 4, 5, 6 dots on it, all of those 6 sides are the surface, right? So if you can find the sum of the areas of each surface, then you have the area of the whole entire three-dimensional figure. Another way to look at it would be, again, if you had, a die or really any three-dimensional figure and you wanted to wrap it as a gift, wrap a gift and give that gift to somebody, and you wanted the entire surface, the entire gift, to be gift wrapped with the minimum amount of wrapping paper that you could use. How much wrapping paper would you use? That's the surface area. Okay, so we're going to be trying to find the surface area of various three-dimensional figures. And the way we'll be teaching it here at Los Altos High School will be a little bit different than what the book introduces. Okay, so the book has you memorize a formula for each different figure. That's not what we're going to do. We're going to basically just add up the sum of the two-dimensional areas, right? Each face is a two-dimensional area. So we're just going to basically add up the areas of the two-dimensional figures that comprise the three-dimensional figure, and that's how we will calculate the surface area. So it's basically what we learned in Chapter 11, right? In Chapter 11 we learned surface area of two-dimensional figures, so all we have to do is just add those up. The only time that I will be introducing a new formula to you is if there is a two-dimensional figure or a surface that was not introduced in Chapter 11. Okay, so with that said, let's move on to our first problem. Find the surface area of a right rectangular prism with height equals 3 inches, length equals 7 inches, and width equals 4 inches. Okay, and here's the picture of a right rectangular prism with dimensions 3, 4, and 7. So please write down this entire prompt, and remember, you are in total control of this presentation. If you need to fast forward it, rewind, pause it, you may do so at your convenience. Okay, you are in total control of this presentation. So you can pause it right now and copy down this prompt, but for the sake of this presentation, I will continue. Okay, so here's the answer. We want to find the surface area. In other words, for example, the minimum amount of wrapping paper it would take to totally wrap up this box, for example, this shoe box, if you wanted to give it as a gift. And you didn't want the person to whom you were giving the gift to know, to read any of the surfaces or whatever. What is the minimum amount of wrapping paper it would take to completely wrap up this surface? Well, first off, surface area will be 7 times 3. So that would be 7 times 3 would be the back surface, right? The rear back of this thing that you kind of really can't see because the rest of the figure is blocking it, right? So that's where you get the 7 times 3 from, right? It's 7 long times 3 tall. So that would be the back area, the back panel of this shoebox, right? But there's 2, and the reason why I say there's 2 is because you also have the front. Okay, the front has the same dimension as the back, right? The front is also 7 by 3. just like the back is. So that's where you get these calculations from. Okay? All right, moving right along. We also have 3 times 4. 3 times 4 would be this length, correct? It's the height is 3, and the depth is 4. So that would be the the left-hand panel of this shoebox, and this would be the right-hand panel of the shoebox. So there's 2 of these panels, 2 of these surface areas that have the same dimension. So that's where you get that 2 from. Okay? And then let's see, going back here. All right. And I guess there's a little mistake that happened here. Hold on. This should be times 2. I guess I inadvertently erased that. Sorry. And then moving right along, you have the top panel is 7 by 4, and the bottom panel is also 7 by 4. So that's where you get the 7 times 4 times 2, correct? And then 7 times 3 times 2 is 42, and 3 times 4 times 2 is 24, and 7 times 4 times 2 is 56. And then adding up, getting the sum, you get that the surface area of this three-dimensional figure, this three-dimensional object, for example a shoebox, is 122 square inches. Okay? Okay, moving right along to our next problem. We have find the surface area of a right cylinder with height h equals 18 centimeters and the radius r equals 10 centimeters. Okay? And here's my figure. You can write down this whole entire prompt. It has a radius of 10 and a height of 8. So how do we find what the surface area of this is? And let's just say this is a drum. Like a drum to, like a musical instrument, a drum, and you're going to, or even like maybe a can of soup or something. You want to give a can of soup to a friend as a birthday gift. Maybe you're not that close with this friend and you want to give them a can of soup for their birthday. So if you wanted to entirely wrap up this gift, this can of soup, what is the minimum amount of wrapping paper you would need to completely hide the surfaces of this gift? Okay, and that's surface area. So the answer is that the surface area is partially comprised of pi r squared, right? So pi r squared, that should be ringing a bell, right? It's the formula for the area of a circle. So we have this, and here's my circle, correct? There's a circle on the top. And the 2 is because there are 2 circles, the top and bottom. Okay? So that's where you get the 2 pi r squared from. And then we have plus 2 pi r h. And 2 pi r h is the surface area of the can part, the part that you touch. Like if you're holding a can, the part that you generally hold, right? It's the sides of the can. And the formula for finding the area of the side of a can or a cylinder is 2 pi r h. 2 pi times r times the radius is the circumference or the distance around this cylinder or this can, and then h is the height. Okay, so if I were to take this cylinder part and if I were to stretch it out or remove the top and the bottom and then stretch it out, I would have basically a rectangle. And the length of this rectangle would be the circumference, right? The distance around this figure is the circumference. So if I were to take it, say, and put a seam right there, or cut it with some scissors, and cut it along right here, and then open it up, I would get a flat rectangle, correct? And this distance, again, would be this distance, which is the circumference. So bear with me for a moment. So this is the circumference, okay, this length. And the circumference is 2 pi r. And this distance is the height. And we know the height or base times height for a rectangle is the formula for the area of a rectangle, right? Formula for the area of a rectangle is base times height. And the base in this case is 2 pi r, and the height is h. Okay, so that's where we get that the formula for the surface area of a cylinder is 2 pi r times the height, h. Okay, and in class I'll have a demonstration that will really solidify this much more, but for now hopefully this helped you. Okay, so this is the formula for finding the surface area of the cylinder part of a can or of a right cylinder. Okay, so let's fill in the values now. So we have that the radius is given as 10, so I plug that in for radius squared, and that's where I get the 10 squared from. And then 2 pi, again, r, radius is 10, and the height is 18. So I'm just plugging in values. Okay, and then calculating this out, we get 100 squared, or rather 10 squared, I'm sorry, is 100 times 2 is 200 pi, and then 2 times 10 times 18 is 360 pi, and so adding up those two you get 560 pi square centimeters. So the surface area of this figure is 560 pi square centimeters, or multiplying 560 by pi you get 1,759.3 square centimeters. Okay? Okay, and there's one more type of problem for which you will be held accountable, and that is a problem like this. Find the radius of a right cylinder with height equals 5 inches and surface area equals 208 pi square feet. So in this case, we know the surface area, and it's our job to find the radius. Okay, so please copy down this prompt. Again, you can pause this if you'd like. But copy down this prompt. I'm going to continue. Again, we know the surface area, and it is our job to find the radius. Okay, so you will also have problems like this. Okay, so here's the answer. It's the same formula as our previous can of soup problem, right? To find the surface area of a right cylinder, it's 2 pi r squared plus 2 pi r h. And then substituting in values, well, I know that my surface area is 208 pi. So that's where I get the 208 pi from, right? I'm substituting that in there. And then that equals 2 pi r squared plus, well, the height is 5. That's where I get the 5 from for height. And then 2 pi r. And it is our task to solve for the radius, r. But I have an r squared here, so it looks like this is going to be a quadratic equation. Okay? And by the way, it seems like we're sort of leaving now geometry, and we're getting back into Algebra 1. Okay, so you can't forget your Algebra 1. And then simplifying further, I get this, right? All I did was multiply 2 times 5 and get 10 pi r. And now I'm noticing that there's a pi in every term. So I can divide out pi in every term and still have an equation that's the same or equivalent to this equation, right? It's 208 equals 2r squared plus 10r. And then I'm going to bring everything on one side to make it look like the quadratic equation, right? We have to have ax squared plus bx plus c equals 0, right? To solve quadratic equations, you need to set them equal to 0. I'm going to notice that now there's a 2 in there's a 2 as a factor in each one of these terms, so I can divide every term by 2 and get r squared plus 5r minus 104 equals 0. Okay, so I have my simplified quadratic equation, and I can solve this one of two ways. I can either solve by factoring or solve by using the quadratic formula. Okay, so I just recopied this down onto this frame. You don't have to do that if you've already written it down. First I'm going to solve by factoring. Okay, so what are two numbers such that when you multiply them you get your third term, negative 104, but when you add them, you get the middle term, positive 5r. So that's what I'm doing here. Again, this should harken back to some Algebra 1 stuff. What two numbers are such that when you multiply them, you get negative 104, but when you add them, you get positive 5. Okay? And those two numbers are negative 8 and positive 13, right? Negative 8 times 13 is negative 104, and negative 8 plus 13 is 5. Okay, so I'm going to take these two numbers, negative 8 and positive 13, and I'm going to substitute them in for 5r, right? 5 is equal to negative 8 plus 13. Negative 8r plus 13r equals 5r. So I just broke up the 5r into negative 8r plus 13r. And then I will group them, okay? And then you factor each binomial. So r squared minus 8r has an r in common. You can pull out an r, and you get r minus 8 left, right? Because r times r is r squared, and r times negative 8 is 8r. So you can, r times r gives you my r squared, r times negative 8 gives you my negative 8r. And then what's in common between 13r and negative 104? What's a common factor? Well, 13, right? There's a 13 in 13, and there's a 13 in negative 104. 13 times negative 8 equals negative 104. So then what I do is I can pull out what's in common here, right? This is called solving by factoring. So I'm going to factor out what's in common. In r times r minus 8 in this term, and in this term, 13 times r minus 8, there's an r minus 8 both times. So I can factor out the r minus 8, and what's left is r plus 13, okay? R plus 13. That's where you get the r plus 13 from. Now I have two binomials equaling 0. When you have two binomials equaling 0, one of them must total 0, right? Any two numbers multiplied by each other, at least one of them has to be 0, right? So we have r equals 8 or r equals negative 13, okay? And since this is a radius, we can't have a negative distance for a radius, and so that answer is not going to make sense. So our answer is r equals 8 centimeters. Okay, so that's solving by factoring. I'm going to do the exact same problem again, starting with this quadratic equation, but this time I'm going to solve by using the quadratic formula. Okay, and so here's my original equation again, r squared plus 5r minus 104, and here's the quadratic formula. The generic form of the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright, and then plugging in the values, okay, if the number in front of the r squared is my a, that means a is 1, and b is positive 5, and c is negative 104. So plug those in, and I get the opposite of b, or the opposite of positive 5, which is negative 5, plus or minus b squared, which is, b squared, which is the 5 squared, or 25, minus 4ac. A is 1 and c is negative 104. 1 times negative 104 is negative 104, all over 2a, or 2 times 1, which is 2. Okay, so that's where you get those numbers from. And then continuing, I get negative 5 plus or minus 21. If you take these numbers and take the square root, you get 21. Negative 5 plus 21 is the same as 21 minus 5. Divided by 21 minus 5 divided by 2, and you get 8. Or negative 5 minus 21 is negative 26 divided by 2, and you get negative 13. So I still get my same answers. Again, the negative 13 doesn't make sense, so I'm stuck with 8 centimeters. So either solving by factoring or solving by the quadratic formula, you choose whatever method you want, you get 8 centimeters. Okay, so the radius of that figure is 8 centimeters. Going back to the picture, here we have that the radius is 8 centimeters. So again, you'll be responsible for problems like that, problems where you're given the surface area and you have to find the one other dimension, either the radius or the height. Okay, that's the end of the notes. If you have any more questions or concerns, always feel welcome to come to me. I would love to help you. It would be my pleasure to help you out. Okay, bye-bye.